Hey guys, it's been a while since I did any decent content, right? Anyhow, this is out of a Toyota Celica. Must be the turbo version. And the tacho slash rev counter is not functioning. It reads very low, if it does read at all. So let's crack it open, not literally, and see if we can't figure that out. Now, what clips have we got holding it together? So we have the black clips are the frame underneath the clear cover. Both are going to have to come off because they both latch into the white housing. So we need to be careful when it comes to these clear covers. You don't put a lot of pressure on the clips or anything. Once a crack starts to form, it's almost as bad as glass. It'll just ruin your day. And the center, not too bad. I can actually use my finger on these ones. Some of them are very tight and you might need a screwdriver to assist. Oh, okay, so the bottom strip comes off separately on that one. And then the center should just come out like so. And that leaves us with access to the gauges, which are, what are they, screwed in from behind or not? Hang on. Alright, yes they are. So we have some screws to remove for the gauge itself. Could it be as simple as that? I have seen loose screws, because these actually form a connection to the flexible PCB on here. So the screw makes contact with the copper pad there, and if they shake loose, then yes, that'll also stop things working. I'm just going to have a bit of a feel and see what that feels like. If they feel loose at all. Where is my screwing stick? It's the trouble when you go do a job somewhere else and you got to take all your tools with you. So let's try that one. I'll just see what it's like to... yes, some movement there, not much. That one's... no, it feels like they were tight to start with. At least tight enough to make a connection, so we don't have to worry about those. So we will pop that off. In fact, it was lifting the flex with the washer underneath, so it shows that it was bonded to it. That one going to do the same thing. Yep. So the washer's sticking to it. And with those out, the gauge itself should lift out. Let's have a closer look. And what can we see? Well, the naked eye doesn't look like a dry joint problem. One I see that's a frequency to voltage converter. We have a diode. Maybe the diode's gone bad. We have that resistor there. Now, is that in the power or is that our signal in? So what I might need to do is just have a look at the PCB there. I should call it a PCF, printed circuit flex. Usually it indicates on here what pin does what. But it looks like they've gone and removed that feature on this particular model. There's no way of knowing. So let's see, we should be able to figure out which one's power and ground, and that only leaves one other. So as I mentioned, now here's our 3 posts. We have one going up to here, and I'm probably going to say that that's our signal line because we we're going to have a common power and ground, aren't we? So this one here, trace runs down here, and it runs to, of all things, it's shared with some light bulbs, and then it heads off up to here and around to here, and then down here. So it goes all over the place. Now it's possibly our positive feed in. I say that possibly because you normally turn a light bulb on by grounding the other side of it, don't you? And automotive, and the other hole, let's see where that goes. That goes down through here, up through here, shared with that one, and over here and onto that one and down onto that one. So I'm thinking this is our positive and this is our ground. So we can look at the circuit and see how right we are when we look at the circuit. So we decided that maybe this is ground and this is power. So if we have a look at, and this is signal, so if we have a look at where it goes in the circuit, that would prove us right or wrong, because there's bound to be a diode in there somewhere. And sure enough, okay, so we have a diode here, right under there, and it's anode cathode, so current would flow in this direction, anode here, cathode on this terminal. Now we're not going to get any current flow from this terminal to the circuit through the diode. So that almost indicates that this is quite possibly our B+, because if you were to reverse polarize this accidentally, then it's going to feed through the diode and create a short that will blow the fuse effectively as protection, because we can only have either positive or negative here. Now let's follow here's our screw hole for what we think is ground. Now if we follow that, we've got our resistor here, the resistor goes to here, it follows down through here to there. Okay, so I got that wrong. I got that wrong. The cathode of the diode is not connected to here, the anode is, because it's running back through under here. If we applied positive to here, it will flow through the resistor into the IC. It also come down to the cathode of the diode, and it won't go anywhere else. If we applied positive to the bottom one, it would come through the diode, back through the resistor, and into this terminal, which would effectively short out through the diode. Current limited by that resistor, which is probably a low resistor. Let's see if I can see what value that is. 24 ohms, possibly 24 ohms. So yeah, it's gonna, so that would be bad. So in that case, this is probably our negative and this is our positive. So if we say this is negative, and I just thought of one other way we can prove that. We just need to find out what that IC is and look at the data sheet, and we know what end the power and ground are. But for the most part, pin 1 through to pin 8, and that goes to here. Pin 8 goes to here. Normally that's ground as well, so pretty sure we're on the right path there, with power and ground being here, power being here, and we also have, it looks like a pin freestanding pin, one there and one there. That must be for factory testing perhaps. You can apply power to both of those, so it makes an easy point for us to connect to, which means the top one is our signal in. The signal in goes via that resistor there, so maybe that resistor's bad, and then straight into the IC. So it comes off the ignition module. I don't know if it's a 12 volt pulse signal or if it's a higher voltage, like a flyback. Often they count the flyback pulses off the coil once it collapses, and maybe that. But we should be able to apply power and a signal and see what happens, but we can do some basic testing first. Does the needle spin freely? That's probably a good start. Yep. So there's nothing wrong with that. It should be able to move. I've not yet seen these ICs fail. It's usually one of these ancillary components like that low resistance resistor. It doesn't look black or anything. We do need to be careful about how we poke around in there, because we do have the mechanism, return spring and so forth, freely accessible, so we don't want to damage that. Let's take a measurement of that blue resistor. And what is the answer? Oh, stay on. 23.6. Nothing wrong with that. Let's check the signal in series resistor. And I don't know what value it should be, but just get an idea. That says 42 k ohm. Alright, so let's have a look at the color bands. And yeah, it should be 43 k ohm. Tell you what, that looks horrible in there. Let me get you a closer look. Let me get you a closer look. Okay, that capacitor looks like it's bulging, like it's gotten either really hot or something. That doesn't look the best at all. It won't take... It's hard to see the bulge, but there's a very subtle bulge, I'm sure, and the sticker around it is definitely rough looking. It's not... She's not smooth at all. And my zoom... I don't have a macro lens, but that's fine. More light there. Look how bulgy that is around the sides. I would say we've hit jackpot. And it's probably a good idea to replace both capacitors if that's the way it's going to be. Alright, let's remove that capacitor and do some testing. Should really suspend that on something so it doesn't flop around. Always think about what you're doing. We don't want to scratch the face of that gauge, so pop some cloth on there. Now I'll just lift the leg. Which side's ground? You know, trying to figure out positive and negative on these. Another quick way would be just to look at a capacitor in circuit, and sure as eggs, the negative is connected to this one. So there you go. That's almost a foolproof way. Yes, some caps connect them backwards depending on signaling and things sometimes, but yeah, lots of ways you can do it. And we should be able to remove that with a little bit of a wiggle left and right. Now straighten the leg up. There we go. And that's a bit better view there. It's all bubbled up around the side. In value we have 25 volt, 10 microfarad. This is going to be a laugh.
Transformers.
What does it measure up at? 9,000 nanofarads. 9 microfarads? Doesn't show microfarad until it hits 10. What a cool tester. ESR 0.2K. 0.2K, 200 ohms. Jeepers. I think we should pop the other one out of here and see what value that is too. It is supposed to be, is it the same? Oh. Looking at that, it's the same capacitor. I bumped it with my finger and it's appears to have split off from its leg. Yep, it's actually come off one of its legs. That one has corroded away as well. Alright, it's getting 2 new capacitors. Let's remove that one. We only need to heat up one side and it's just going to pop out like a rocket. Ooh, yeah. Looks a bit rusty and so forth around the base. Let's get that other leg out. But we got it. Okay. You're not going to believe what I just did. So I'm right-handed for using the solder iron, except this time I was using it in my left hand while I held the tweezers, and I just hung up my tweezers in the solder iron holder. That's hilarious. Cool. Okay, let me find some replacement capacitors. Well, I have a couple of 10 mic 50 volt, luckily. I don't know why they had to make these ones so tiny physically. There's plenty of room under there, so no worries there. Let's pop those in. And we said ground was that way. Oh, okay. Let me just clear off the solder so that I can feed the legs through. I wonder if we have a test point standoff for the input signal. I don't see one. Okay, I got my signal gen set up, square wave, 1.5 volts amplitude, starting at ground, and 30 hertz. We got there, 30 hertz. Turn on the output. We get 1000 RPM at 30 hertz. I'm not 100% sure if that is accurate, but given that if we go up to 60 hertz, she's almost there, 2000, then 90 hertz, 100 hertz is 3000, so I'm not sure exactly what it's supposed to be, but if we go up to 200 hertz, she's pretty close to 6, and then 300 hertz, she's pretty close to 9. So without knowing exactly what the waveform should be, I think that's looking like it's somewhat consistent, but it's definitely moving. I think we can throw it back in the car and it will probably be absolutely fine. Now of course with the screw hole for the signal input, it does go through that resistor, that 43K resistor. So I've actually clipped onto the other side of the resistor because I had to really crank up the output on the SIGGEN and it wasn't giving me anything, so I started low and went off that side of the resistor and it was perfectly fine. So it must be measuring flyback voltage, which is quite high, and I can't replicate that from my signal gen, so we can clip on here and use a much lower voltage and it will still count and give us a reading. Right, get it back in the box. We are up that way. Now fingerprints can be annoying to clean off, so I might just support the face of it with the rag, and we won't have to worry about that if it did leave a mark. You can clean it off with some iso alcohol of course, but some of those nice black surfaces, the texture they use does love to pick up fingerprints. Don't forget the bottom strip, it was separate for some reason. Make sure the clips tuck under and don't get pushed out of alignment. Like, why is that not clipping? I'll get the top one to clip in, that might help. There it goes. And of course you all know the trick to wind the screw backwards until you feel it drop into the thread so that you don't end up cross-threading it. Well, there we go. One gauge repaired. Pretty straightforward. It's usually our surrounding component failure on those gauges. It's not usually the chip itself that I've ever seen, but I guess it could happen. There we are, another one. Done and dusted. Thanks for watching.